Welcome to this mechanics video, M2, on differentiating vectors. So we can use calculus with vectors to solve problems involving motion in 2D, okay, with a variable acceleration. Now, to differentiate a vector quantity in the form of something I plus something j, we basically just differentiate each function separately. So r is xi plus yj. Now r is like a distance or displacement. Okay, so when I differentiate r, so dr by dt, then what I get is actually going to become the volume. Okay, and that's going to be just then x differentiated and y differentiated. And then when I differentiate, did I say volume then? Velocity. What am I talking about? When I differentiate the velocity, that's going to become the acceleration. Okay, and that's the second differential in front of I, and the second differential of the y term in front of j. Okay, now I think it makes way more sense if we do it with an example or two, so let's have a look at some. So, particle P of mass 0.4 kilograms is moving so that its position vector r meters at time t seconds is given by this equation, or this vector equation. Calculate the speed of P when t equals 3, and then find the acceleration when t equals 2, and find the magnitude, the acceleration as a vector, and then find the magnitude of the acceleration at this point. So let's start off with A. So we're going to find the velocity, and that is dr by dt. So that's going to be 2t plus 4i plus 3 minus 3t squared j. So all I'm doing is differentiating the I term and the j term separately. Okay, so 2t plus 4 when I differentiate this, and 3 minus 3t squared when I differentiate that. Now I've got t equals to 3, which I need to substitute in. So my velocity is 6 plus 4i plus 3 minus, what's that, 3 squared is 9 times 3, 27j, or 10i minus 24j. Now that's the velocity as a vector. We want the speed, so we want the magnitude of that velocity. So that is with Pythagoras. So 10 squared plus minus 24 squared. And that then will be square rooted. And that's going to be the square root of 676, which is 26 meters per second. Okay, so that's part A done. Now let's move on to part B. So the acceleration is what we want to find. Now the acceleration is either the r, the distance, the displacement, differentiated twice, or the velocity differentiated once, because they're both the same thing. Okay, this and this, because to get the velocity I've already differentiated r once and differentiate the velocity and I get the acceleration. Okay, so I'm just differentiating this. So 2t plus 4i becomes 2 I, and then the 3 goes and it becomes minus 6tj. So that is now my acceleration. So we've got to find the acceleration when t equals 2. So when t equals 2, this is going to be 2I minus 12j meters per second squared. And this is kind of the part 1. And then the part 2, the magnitude of the acceleration at this point is the size of that, so it's going to be two squared plus minus 12 squared, which is 2 root 37 meters per second squared. We can also write that the magnitude of A is written like this, so A inside a modular sign. And there we have the first example. Now let's look at another example, but this one will be a past exam question. So it's a bit longer. Past exam question. Particle P is initially at a fixed point, a fixed origin O, at a time t equals 0. P is projected from O and moves so that at a time t seconds after the projection, its position vector r meters relative to O is given by this equation here. So find the speed of projection of P. Right, I'll read the rest when we get to it. So part A is to find the speed of projection of P. So we need to find the velocity, that's dr by dt. So that's going to be 3t squared minus 12I plus 8t minus 6j. And just rewrite that just so it's a little bit better. There we are. Now we want the speed of projection, so that is when t equals to 0. So my v is 0 minus 12I plus 0 minus 6j. So minus 12I minus 6j. Now that's the velocity as a vector. We want the speed. So the speed is the modulus of the velocity. So that is going to be minus 12 squared plus minus 6 squared and then square rooted, which is 6 root 5 meters per second. Okay, the second part, the value of t at the instant when p is moving parallel to j. So if it's moving parallel to j, means it's only moving vertically at that point, means there's no I component. So we want to find the value of t then. Okay, and that's going to be of its velocity. So when its velocity only has a j component, so this means that 3t squared minus 12 will be equal to 0. So 3t squared equals 12, t squared equals 4, t equals plus or minus 2, and obviously t equals 2 because we can't have a negative time. Okay, and that there is part B done. Now part C, the position vector of P at the instant when P is moving parallel to J. So the position vector is going to be this R, and what we know is that T equals 2, so we're going to do for C, when t equals 2, r equals, so 2 cubed is 8 minus 12 times 2 is 24. And then we've got 2 squared is 4 times by 4 is 16 minus 6 times 2 is 12. So just substituting 2 into my R formula. So 24 minus, 8 minus 24 is negative 16i, and then 16 minus 12 is 4j. So it's negative 16i plus 4j. So that's the position vector. And you could say that's in meters if you so wished. Okay, now on to the final bit. So the motion of the particle is due to it being acted on by a single variable force F in newtons. Given that the mass of the particle is 0.5 kilograms, find the magnitude of F when t equals 5. So we need to find the acceleration. The acceleration is differentiating the velocity. So that's going to become 6t I plus 8j. When t equals 5, the acceleration is going to be 30i plus 8j. Now for force F equals ma, the mass was 0.5 and the acceleration is 30i plus 8j. So that is going to be 15i plus 4j newtons, which then, if we want the magnitude of that, we're going to have to do 15 squared plus 4 squared and then square root it. And that's the square root of 241, or 15.5 newtons to 1 decimal place. I can't quite fit that in the corner, so I will leave it where it is. Okay, or 3 significant figures if you wish. Now that is an exam question on this. Hopefully that was straightforward and easy to follow. If you found the video useful so far, hit that like button. Don't forget to subscribe if you're yet to subscribe. Maybe you didn't find this video useful, but maybe you are studying maths. So hit that subscribe button and then you'll always be able to find my videos. And if you are here long time, appreciate my videos and want to help me out financially, then hit that join button. Okay, you don't have to join for long. You can join for just a month, you can join for longer. Okay, just give a little bit back if you can. It does help me out and enables me to make more videos. Right, let's look at a few questions. So here we have some questions. I've got 5 questions in total. Pause the video now to have a go at questions 1, 2 and 3. Okay, let's look at 4 and 5. And pause the video now to have a go at 4 and 5. And welcome back. Right, let's have a go at a few questions. Let's try them out. See if you've got the right answers. Sorry, I kind of wrote it off the page a little bit there. There we are, you should be able to see the answers now. Okay, so we want to find the speed or the value of k. So the velocity is dr by dt, which is going to be 20 minus 6t squared I plus 2ktj. And then when t equals 2, the velocity is going to be 20 minus 6 times 4, 24i plus 4kj. So the 2t, 2 times 2, 4. So I've left with minus 4i plus 4kj. Now obviously we want the speed. Speed is 16, so that's going to be the Pythagoras. So this would mean that the square root of minus 4 squared plus 4k squared is equal to 16. Now what I can do is, to get rid of the square root, square both sides. So 16 squared is 256. And now I've got rid of the square root, so minus 4 squared is 16, plus, and the 4k squared is 16k squared. So 256 minus 16 is 240, divided by 16, so k squared is 15, so k equals the square root of 15, so plus or minus the square root of 15. Now it says up here k is a positive constant, therefore k equals square root of 15, just the positive one. So that's my part A done. Now part B, the acceleration of p at the instant when it is moving parallel to j. So when it's moving parallel to j, means it's moving vertically, means there's no I component of its speed. Okay, so when we're looking at the velocity, the I part is 20 minus 6t squared, and that is going to be equal to 0. So 6t squared equals 20. So t squared will be 20 divided by 6, or 10 over 3. T equals the square root of 10 over 3. Obviously just the positive as we want, as time is only positive. So we've worked out t, we need to work out what A is. So dv by dt, so that is minus 12i. Now, plus, now it's 2kj, but k is the root of 15, so it's 2 root 15j. Sorry, it's minus 12 ti. Missed out the t there. Okay, now substituting in t equals this root 10 over 3, and we get that the acceleration is minus 12 times root 10 over 3 plus 2 root 15, and that's j, and that one is I. And then just in your calculator to simplify it, so minus 4 root 30i plus 2 root 15j j. Okay, and then that's it. If you want to find the magnitude, you can, but it doesn't ask for the magnitude, so I would probably stop there myself. Right, let's look at question 4. Okay, so this is now involving impulse from M1. Okay, and we want to find the velocity. So let's find that as a vector first of all. So we want to find the velocity. So dr by dt is going to be 2t plus 4I plus 3 minus 3t squared j. Okay, now let's look at the velocity just before the impulse. So when t equals 3, then it gets an impulse. So just before impulse, t equals 3, so the velocity is 6 plus 4I plus 3 minus 27j. So it's going to be 10I minus 24j. So that is the velocity before. So I'm going to put v with a little b there. Now let's look at the impulse formula. So this is the change in momentum, isn't it? So the final momentum minus the initial momentum. So this is my formula. Now, I know the impulse, that is 8I minus 12j. And if I take the factorize out the mass, which is 0.4, then I have my velocity, which I'm trying to find immediately afterwards, and then my initial velocity. So my initial velocity is equal to that VB, velocity before. Okay, so let's divide by 0.4, so 8I minus 12j divided by 0.4 equals the velocity I'm trying to find minus 10I minus 24j. Now I want to do 8 divided by 0.4, so that gives me 20I minus 12 divided by 0.4, so minus 30j equals V. Now I want to take this to the other side. So well, I'll keep it on this side for now. So V equals 20I minus 30j plus 10I minus 24j. So just carrying on up here, V is going to be 30I minus 54j. Okay, and that is the speed in meters per second, or the velocity I should say, not speed. That would be the velocity. If it asked for speed, then we would find the modulus of that. So hopefully that one made sense, a little bit different. Let me know in the comments if you managed to get this one out. Okay, so this one we are going to need to find the magnitude of F, so we're going to basically need to use F equals ma, which means we want the acceleration. So that is to differentiate the velocity. So it's going to be 6I plus 2t plus 3j. Okay, now when t equals 4, a is going to be equal to 6I. This is going to be 2 4s are 8, plus 3 is 11. So the acceleration is 6i plus 11j, and that's meters per second squared. Now F equals MA comes in. M is 0.4 and A is 6i plus 11j. So now I go 0.4 times 6, that's going to be 2.4i, and 0.4 times 11, that's going to be 4.4j. And that is newtons. Okay, and that is all there is to this problem. Okay, the magnitude, obviously, if we want to find the actual magnitude of F, oh no, it is calculate the magnitude of F. Oh, so we need to go a little bit further, and we need to use Pythagoras. Comes from Pythagoras anyway. So 2.4 squared plus 4.4 squared is 628 over 25. Square root in that, so this is 2 root 157 over 2, or 5.01 newtons to 3 significant figures. So that is the magnitude of F. Hopefully you found this video useful. Okay, few exam questions in there just to throw you off, challenge you a little bit. But like I said, hopefully you found this useful. If you did, hit that like button. Don't forget to hit the subscribe button if you're yet to subscribe. And if you're willing and able to help me out, then hit that join button. I know I don't offer much, okay, for a member. Members do get some of my videos a little bit early, but only a few days. But in terms of questions, I'm getting quite a lot of questions, you know, every day, and I can't possibly answer them all. So I do prioritize questions from members. So that is, you know, what I can really help out with. Okay, and if you go to the higher tier of the members, then I can make, and I have made, like individual videos for those members on individual questions when they're stuck revising. So it is potentially worth it for you guys, but obviously, you know, if you want to do it just to give a little bit back to me, that would help out massively as well. Anyway, right, I'm going to crack on and finish this M2. Well, not tonight, but over the next few weeks, hopefully we'll finish the M2 course. I'll be doing the videos alongside doing the FP2 videos, so do bear with me.